Chris goes.
Recording. Hello and welcome to the Roundtable Podcast. I am Shogun. Thank you to our live audience for joining us today. Welcome, everybody. I'm really looking forward to this. Before I go any further, please join us on the Roundtable Discord server. You can find us through the conspiracy or politics sections of Discord, or just Google Roundtable Discord on Google. You can find us on all social media, Facebook, Instagram, etc. You also can find our website and forum community, roundtablediscord.com, I think. And that being said, join us on server. So today we're doing the Great Roundtable Flat Earth Debate. This is actually the third Flat Earth debate that we've had on the server. One was a big 60-person debate. The other one was a one-on-one debate between myself and a Flat Earther, but those were not recorded. So this will be the first Roundtable recorded Flat Earth event. Today, our debaters will be our very own head administrator, Machina, Deus Ex Machina to be precise, my very dear friend. And opposing him shall be my old friend and colleague and moderator, Nate, by the name of Chris the Flat Earther, who I've had the pleasure of talking to and listening to about Flat Earth several times before, as well as other subjects. So this will be a roundtable adversarial format, formal moderated debate. I can't remember if we did a recorded debate like this yet or not, but the way they work is either 5 or 3 rounds of 5 minutes each. This debate will be 5 rounds of 5 minutes each. Each person gets their 5 minutes uninterrupted. There'll be no interruptions from the audience or from their opponent. Then the moderator will simply tell them when they have 1 minute remaining, and then when they're out of time. Then it will be the opponent's turn, and it will go round 1, turn 1, round 2, turn 2, etc., until everybody has had an equal 5 minutes, 5 rounds to make their case. In this case, for the flat Earth or against the flat Earth, or to put it differently, for the flat Earth or for the spherical Earth. However you want to look at it, for or against the flat Earth theory. So, our moderator today will be Sir Polly, and an excellent moderator he is. A good friend and knight of the server. So, thank you, Polly. Thank you, Machina. Thank you, Chris. Are there any questions before we get started?
Nope.
All right. So, of course, logic, reason, and evidence are priorities here. To make the case with logic, reason, and evidence, you can use your time and you approach the problem any way you wish. You can respond to your opponent's claims, or you can, it's up to you how you use your time, but try to respond to valid points, whatever makes sense to you in terms of how to make a compelling argument. You guys get the idea. So, Paulie, do you have a timer ready?
I do, my friend.
All right, thank you. So round 1, so the case, the first person to make the case should be the one sort of making probably the positive case. So in this case, I think it makes most sense for Chris the Flat Earther to go first and make his 5-minute claim of why the Earth is flat, since that is sort of the extraordinary case here, whereas the Earth being spherical is the default position. So I think that makes sense. Are you guys agreeable to Chris going first?
I am.
Chris, are you okay with going first?
Yeah, I can do that.
Okay, great. So, Paulie, you have the timer ready. You can simply say whenever you're ready or whatever you're going to, but what you try and do is just say round 1, start, round 2, start, because believe it or not, it's easy to forget what round you're on. So, yeah, you have the timer, and then Paulie, just let him know when he can start, and then for each person, you'll tell them when they have 1 minute remaining and when they're out of time. Sorry.
Perfect. Chris, you ready to go?
Yes, sir.
All right, here we go. 3, 2, 1.
Okay, so I believe the Earth is a flat stationary plane with a glass-like dome over it. I believe the North Pole is the very center, and Antarctica is the ice wall around us. I believe the Sun and the Moon are the exact same size of each other, and they circle above us. I believe all the stars are lights, and they also move in a route formation. I believe my model explains that there's absolutely no curvature, there's no spin. My model also explains why the Sun, when it's observed, the sun rays are coming down on divergent angles, not parallel. and that's why the sun is the exact same size as the moon. Also, that's why you see the same face of the moon every night, because the moon is just another light in the sky. And also, the craters on the moon are all perfectly circular. That means that every asteroid would have to hit it at a 9-degree angle, which is physically impossible. That also explains why when you measure moonlight, it's cold. I believe the sun emits heat, the moon takes in heat. I believe the stars are all moving in a route in my model. It explains it, and the globe model actually explains that the stars you will get stellar parallax over a period amount of time. But the stars, when you observe them, they all move in perfect synchronicity. The constellations have never changed. That's why you can use the stars to navigate. Another thing is, I believe water seeks its level. It never curves. That's why when ships move away, they move away. They don't sail over a horizon. It's just due to the law of perspective. I believe there's a glass-like dome over us, and I believe it explains why rainbows are the same shape of the dome, because when you shine light through a dome, light takes the shape of the medium it moves through. If sunlight is moving through a glass-like dome, that's why when the sunlight shines onto the water droplets, it creates that dome effect. Hence why you look down at the rainbow, it's circular, because the dome is also circular. Also, sundogs are a reflective effect of the dome. And I think that's it. Also, I don't believe the Earth can exist next to a vacuum, because the atmosphere would depressurize and gravity would get weaker the higher up you go. Also, if the Earth was a ball, there would be a Coriolis effect. That means the atmosphere would spin separately from the Earth. It's called a blender effect. The middle of the blender would spin faster than the outer portions of the blender. Therefore, the atmosphere would spin separately from the Earth, which we don't observe. That's basically it.
So I am going to encourage you to try and use your time. You can definitely yield your time, right? So you can give up your remaining time to your opponent, but it will be best if you try your best to, elaborate your points, make as many points as you can in the time you have, make a strong case if you can, even if it's just stuff you remember from. That will be best for the episode and also for your case. So that's what I recommend, but you can yield time up.
All right, so I'm going to yield.
Chris, you do have 220 left.
I'm good.
Okay.
That's up to you. All right, so sorry, Paulie.
Deuce, you ready to go?
Oh yeah, I'm ready.
Go.
Okay, so first of all, that was a lot of claims you made. So I'm just gonna stick to one for now, and that's the dome. So let's assume that there is in fact a dome around the Earth, and the Earth is a disk, according to your model. Now, if that was true, then that means that there is a barrier, a physical barrier around the Earth that, I'm assuming it's solid since it can hold air. I'm assuming it's also probably transparent. I don't know if the sun is in the atmosphere or outside the atmosphere in your model, but we do know that the atmosphere is really thin, and this is very easy to explain, but let me just go around and say that it's not that much, like 100 kilometers or even less. And then the thing is, the pressure drops really rapidly, actually, as you increase altitude. So there's a gradient in pressure. And that's very easy to observe. You can literally and this is an easy experiment, get a balloon, get a barometer, make sure the balloon is light enough that it can carry, big enough that it can carry the barometer, and then have some sort of electronic signal that sends the information down, or it could just go up and then come down, and there's some recording, and then you pick it up and you read the recording. The point is, you will notice that there is indeed a shift in pressure, a very significant shift in pressure. In fact, we use this all the time when we fly, because drag actually becomes very significant when you're traveling at high velocities. So it's very important to actually go up as much as possible. Now, we would preferably go to space if we could, but there's a problem with engines, which requires oxygen, and at a certain point, the atmosphere is just too thin to support it. So that's why we're limited. Of course, if we have an oxygen tank, then we're no longer limited, actually, and we can indeed leave the Earth's atmosphere, and we have many, many, many times with satellites. In fact, I was there during the GRACE satellite launch, which is actually like a twin satellite that orbits the Earth. and detects very slight variations in Earth's gravity and maps it. It's very interesting. But okay, so let's go with gravity now. Okay, so I'm gonna have to ask you a question. It's really important. What is gravity in your opinion? Like, how does it work?
Stereotype.
I yield my time.
Okay, so in my model,
No, hold on. So you let the moderator, then we'll say round 2, and then he'll say Chris, and then he'll start the timer. So let the moderator cue you of when to start, and then the moderator will always say round 1 turn, 2 turn, round 2. Okay, and so now it's going to go to Polly, and then Polly will start the time for you.
All right, yeah, round 2, and Chris, when you're ready to go.
okay, so you stated that.
I'm really sorry, but everybody who's not part of the debate, please close your mic. Everybody who's not part of the debate, anyone other than Polly, Chris, please close your mic because we're hearing background noise, etc.
All right, Chris, sorry, we'll start that again. Go ahead.
Okay, so you're saying that in my model, there wouldn't be a pressure gradient. Actually, this is gases function as fluids, right? So just like the lower you go in the sea, the higher the pressure there is because there's more water acting upon it. That's exactly what gas does. So yes, there would be a pressure gradient because there's more air acting at the bottom levels than the top. And another thing is, so you're asking me, so I don't believe in gravity. I need something to substitute it, right? So I believe that things fall down due to its relative density. I believe downward is objective. We all have the same downward, and we're in a system that was designed to pull things downward based off its density. Hence why helium balloons rise. Helium isn't anti-gravity, it's just lighter than air. I yield my time.
So,
All right,
Chris, hold on. I need to explain something. So, Chris, if you don't use more of your time than this, then there's no possible way you can meaningfully win the debate. The art of this is to fill this time with content that the listeners will be convinced by, that will convince them of why the Earth is flat. If you're only using 1 or 2 minutes of your debate, then you're not going to be, A, you're not going to make a good event, and B, you're not going to make a good debate. So, you are a flat earther. You've studied this for a long time. You've talked about this for a long time. So just simply speak about flat earth and tell us why you believe in it, what makes you believe in it, what the evidence is, etc. Use your time. Otherwise, this will be a disappointing event for everybody.
Okay, so I'm going to go ask you a question about your model now. So I want to know, so just like the claim I made before, I want to understand why the atmosphere doesn't depressurize into the vacuum of space. Because gravity is stronger the closer it is to the center of mass. So at ground level, what we experience right now, it should be the strongest force of gravity that's acting upon the gases. The higher up you go, the more it would depressurize. So if I start removing gases at this level, it would just it would fill the vacuum. Like a pressurized atmosphere cannot exist next to a vacuum without a container. I want to know, why won't we depressurize? I'm going to ask another question after that. Just like I said, the Coriolis effect, why doesn't the atmosphere spin separately from the Earth? I yield my time.
So you don't have to yield your time. You can ask questions as part of your time, and then Makina can answer them, and that will be considered part of your time that Paul is keeping, and then you can continue your dialogue. So you don't need to yield your time. When you ask a question, he can answer, and you can continue.
Oh, okay. All right.
All right. Yeah, okay, then I'll answer it in your time, I guess. So for one, you yourself admitted that there is indeed a gradient of pressure. If we follow that idea logically, the more you extend it, the lower the pressure will get, and at some point, it will reach zero pressure, hence vacuum. And you're right, absolutely, it is indeed the weight that creates the pressure, because there's more water on top in the ocean. For example, the bottom is higher pressure. Absolutely correct. So if you follow that same exact logic and continue it all the way to the edge, you will indeed eventually reach vacuum, as a gradient usually does. Just X pressure approaching zero. And you can observe this very clearly. If there was a dome, and if there was a dome, and if the Earth is spinning, now I don't exactly know the model very well, but I would assume that there has to be
Well, I just
a
want to say, make sure
variation
you're only
in.
answering the question. You may be, but as long as you're only answering the question and then yielding the time back as soon as you have in the way that you think is appropriate for the question.
Sure. I mean, this was somewhat related, but sure, I'll yield it.
So just to explain, you can ask yes or no questions of your opponent, and then they have to say yes or no. If you choose to ask an open-ended question, then however long they take to answer it is out of your own time. So that's how that works. But anyways, continue, please, Chris.
Okay, so you stated that the pressure would reach 0 the higher up you go, right?
Yes.
Okay, so I don't actually agree with that. I don't believe, just like water doesn't reach the pressure of 0 as soon as you hit the top levels of water. There's still a certain amount of pressure. I'm asking you, at what altitude would the pressure? I mean, would the atmosphere leak out into the vacuum of space?
I don't know if it's still your time. You're asking me a question, so I'll answer it. And as you pointed out, there is something known as weight. Now, I don't know what you want to call it. You don't want to call it gravity. You want to call it whatever. We do know that things tend to go down. I mean, that's very easy to observe. And there is a force. We can feel it. So when you pick like a 10-pound weight, you feel the force. So with that very basic understanding, we get that, it is actually, the atmosphere is actually keeping itself essentially, with, of course, the assistance of the gravity of Earth holding it in. So it's falling down towards Earth, therefore not escaping into the vacuum. Literally, it's constantly falling down towards the Earth. That's why it doesn't escape. Okay, anyways, I'm done.
Chris,
But-
you're at 1 minute.
Okay, but if gravity, like I said, so at the bottom levels where we're at right now, the closer we are to the center of mass, air is able to freely move in this area. It doesn't act as in a container, right? So why wouldn't it just depressurize once we hit the right next to the vacuum? I don't understand that.
As I was saying, the weight, right? It's falling down towards the Earth. It is. Let's just think of it as an experiment this way. Imagine there's a bunch of people just jumping on top of each other, okay? And it just goes on like a forever, right? It's a bunch of like mini people jumping on top of each other. They're all falling down eventually, and they're all gonna fall on top of each other. No one is gonna jump and all of a sudden go into orbit. It takes a lot of energy for that to happen. So yes, the atmosphere will thin significantly. Actually, temperature increases also. There's like plasma and shit like that, which is really weird, like low temperature, high pressure. But yeah,
That's time.
Clearly.
Okay, so that was your time, Chris. I just want to say it's up to you how you use your time. However, as you can tell, the effective way to use this time is to spend 5 minutes articulating every possible argument, reason, proof, logic, and evidence that you have of why the Earth is flat. So from the beginning of that 5 minutes to the end of the 5 minutes, the best thing you can do is explain to the audience why you believe the Earth is flat, why you ever doubted the Earth was a sphere, what evidence convinced you, what reasons you doubt the globe. You have a certain amount of time, and in that time you want to explain to the audience why you believe what you believe and why they should believe the same. Explain to us in 25 minutes why you are Chris, the flat earther. So you can ask questions, but then you're just giving him your time, and then he's making his case on your time. So that's not effective debating. So you're going to want to keep the questions to yes or no and to a minimum, and generally only as rhetorical. Otherwise, it won't be a debate. It'll be Makina talking in your time and Makina talking on his time, because now it's going back to him, and he talked for most of your event there. So in the future, I would recommend avoid questions, make your case. But now it's Deuce's turn. Go ahead, Makina, or sorry, Paulie.
All right, Deuce, you ready, bud?
Yeah, I prefer to be called Makina, seriously, but yeah.
Sorry.
All right, go ahead.
All right, so there's a few other things I would like to mention, because there was a lot of stuff that, initially I was introduced to by Chris, Flat Earther. I don't remember most of it, but I do remember one of them, actually, on top of my head, and that was the sun's rays, how they seem to diverge. That is not true at all. it's a optical illusion. Actually, sun's rays are known to be very parallel. Actually, it's amazing, and the reason it is actually that parallel is because it is so fucking far away. So that's just what happens. And also, you can see this, with like if you get a lamp, the shadow becomes blurrier as you get closer to the source, and then the more you're towards like the wall and further away from it, the crisper and sharper it becomes. And the sharpness, of the sun's rays it's quite evident, especially because it's so freaking far away. It's kind of like a laser at this point, how straight the rays are. Yeah, let me actually talk about a couple experiments that can be done. Okay, because let's focus on gravity here, because I think that is above all else the key behind everything else. So, for one, we have to see if there's an experiment for gravity. Now, we do know that there is, in fact, a evidence known as the Cavendish experiment, and it's really a basic experiment. It's essentially like two big weights on a long thing hanging from something, and then you bring a weight, to one of those two like heavy lead balls that are going to counter, balancing each other or something, and when it gets really close to it, it will slowly move towards it. Now, this we can, of course, because this is science, you got to test it with different materials, eliminate any possible, variations or other sources of interference. So if it's, magnetic or something, we can try with different minerals and materials. And then we can, do a delta and see what the difference is. If it's the only thing that changes is the mass, and if the force changes with the mass, with a perfect correlation, 1-to-1 correlation, then that means the mass is, in fact, the cause, or there's at least 100% correlation between mass and gravity. So that with that knowledge, and with the knowledge of knowing how to measure the weight of atoms, which isn't that difficult, you need a mass spectrometer. Essentially, it's you throw an atom. Okay, an ion. I think an ion is preferably, what is used. But point is, you shoot an ion, and then there's a magnet or something that deflects it. And the heavier it is, the less it will deflect. The lighter it is, the more it will deflect. This is because of momentum. So with that knowledge, with all these experiments, we can do some basic math and get a rough estimate for how massive the Earth has to be for it to have this acceleration, which is 9.8 meters per second. We can calculate that. So that's interesting. I also have a question to you, Chris. You said that gravity is stronger at the base, right? At this, the closer you get to the ground. What do you have for that? Like, what reasoning do you have to support that? And I don't yield my time, but I'm asking you a question, so feel free to answer.
Why do I believe that gravity gets stronger when it's getting closer to the center of mass?
Yes.
The same reason you believe in black holes.
Okay, so from what I can understand from that, is that you also believe that there is a correlation between mass and gravity. Okay, that's good. So with that said, let's talk about a few other things. So we know how heavy atoms are. We know gravity is there. We can measure the force in a lab. Easy, not that expensive, actually. Now, we also know stress, how strong materials are, how powerful they are, And then we can just without even much effort, we can just think of this thought experiment.
30 seconds.
Imagine you have this big lump of matter, just this gigantic lump, really dense too, What would happen if it has a powerful gravitational field, and if this gravitational field expands in all directions? Well, it will form a ball that is the most stable, balanced pattern for it, and it's the lowest energy state. I'm done.
All right, Chris, this is going to be our fourth round, so we're 20 minutes in. Go ahead.
Is this the fourth round already?
Yeah, the
yield. I don't think this is the fourth round. Because remember, it doesn't go round one, round two. It goes round one, round one, round two, round two, round three, round three. So one cycle I don't think you've had 4 turns each.
They're going in their fourth right now.
Is that correct? Okay. All right.
Okay, so he stated that the Coriolis effect, not the Coriolis effect, the Cavendish experiment proved the gravitational attraction. I just want to ask you one question. Where was this experiment done at? Like, was it done in a vacuum chamber? Was it done just in the middle of a classroom? Or, if you don't mind answering real quick.
Yeah, this experiment is done at colleges all over the world. I have not had the pleasure of doing it myself, unfortunately, but there's thousands of footage by people on YouTube doing it, I believe. If not, it's okay, you can do it yourself very easily. It's a very cheap experiment to make, really. I mean, it's not cheap, but I mean, if your faith of your world is depending on it, then it is in fact a very cheap price to pay to verify if there is indeed a measurable force. As for gravity, because you mentioned like vacuum, sorry. As for vacuum, you can of course run the test inside a vacuum chamber, although you would need a very fucking big one for that, that would be a little expensive. You'll probably be able to rent a vacuum lab or something from NASA or some shit. I'm sure you can do that.
This is actually Chris's turn, right? So Chris, please take your time, make your case.
Okay, so the problem was, so since it's not being done in a vacuum chamber, and not only that, it's also, you can't isolate for gravity because you're in a system that is basically pulling things downward because it's based off gravity, right? So the experiment wouldn't work unless it's in a vacuum and unless you can isolate for it. Therefore, if you're outside of the gravitational attraction and you are having a gravitational pull, like if you put the two balls together in space, that would only prove the model. All right, so another thing I wanted to say was, you're saying that the rays of the sun are an optical illusion, but if you observe the sun that's farther away, you can see the sun rays. It's actually not an optical illusion, because if it would be parallel and it would look like an illusion if the sun rays were directly pointing at you. Like if you look to the left and right, the sun rays would be coming on different angles because of your perspective. But actually, if you look up the sun, I posted in special events, by the way, when it's farther away, they're also coming down on different angles. Another thing is, so you're saying that we can't feel I'm guessing that you can't feel a spin because of gravity, right? Because can you answer real quick?
You can't feel it because the Earth is fucking massive. That you can do the formula, but essentially, and this is interesting because this was something I was interested in. There is a 0.0, I think, 0.03 meter per second or 0.03 meters per second change between the pole and the equator in terms of centripetal force.
Hold on, can I answer your question real quick?
Yeah.
I just want to, because my time's almost up. So the problem with that is, all right, so if we're spinning right now, actually, if we're on the outside of the Earth, like if we're getting closer to the equator, the more we get to the axis, the slower we should be spinning. So if I start flying to the axis of the North Pole, it should be spinning slower. Another problem with that is the Earth is also going around the sun on an ellipsis. That means as soon as it gets closer to the sun, as soon as it takes that turn, the Earth should be actually getting faster. I'm going to show you a little description on the model if you guys look in special events real quick. It's taking an elliptical orbit, so actually when it's spinning around the sun, it's actually getting faster and slower every season. So once you get closer to the sun, you should feel a speed change. Any speed change you should feel. It's conservation of angular momentum, Hold on, let me think. And another thing with gravity, everything moves downward at a set rate of 9.8 meters per second squared, and due to the law of gravity, like
1 minute.
They claim it 1 minute. All right. So due to the law of gravity, what happens is since you're getting closer to the center of mass, the acceleration actually should get less the higher up you go. And not only that, things with more mass should have more gravitation. So a bowling ball should actually fall faster than a feather in a vacuum, but yet it does not. I'm going to yield my time. That's basically it.
Yeah. Sorry, Paul wants to go first.
Yeah, I'll hop in there. Okay, so this is going to be your fourth round, Mechana. So you ready to go? 3, 2, 1.
Yeah, sure. Sorry, my thoughts are a little jumbled here. For the parallel rays, that is, I'll explain to you what that really is. Kind of, it's like the railways, the train railways. If you look at it, from any angle, right? Essentially, it doesn't have to be directly at it. It will seem like it's, because of perspective, it is moving. Like when it's moving away from you, it's moving towards a center point, kind of, and when it's moving towards you, it's moving away, kind of. That's just the way perspective works. So that's that. That's very clear, actually. As for the Coriolis effect, I'm gonna actually go into that a little bit because I want everyone to understand what a simple concept this really is. So the Earth is spinning, okay, in the globe model, all right, and obviously at the equator, it's the momentum, the angular momentum is higher, obviously, than the pole because we're rotating at a much faster speed than if horizontally, at least. So what would happen if you were to go up or down? What would happen? Well, the velocities are actually different as you're going towards the pole. So if you were going up, because you were going right faster, it's going to look like you're curving inward to the left if you go up from the equator, and vice versa for the other way around. This is you can demonstrate it by just getting a ball, moving your finger up, from the equator. While rotating it, you'll see kind of how it's going to move. It's very simple. You have higher, horizontal velocity at the equator than you do at the pole. Therefore, there is a very easy and measurable effect. In fact, snipers have to account for this. I'm pretty sure in naval battles you have to account for this, considering the range. And in artillery, I'm pretty sure you definitely have to consider that. And of course, there's many other things. And of course, this is war, so people don't have the time to play games. If you're calculating something, you better fucking make sure it works, because this is life and death. So they wouldn't, for a conspiracy reason, add that there. Now, there was another thing you mentioned, and I don't know why I'm having trouble remembering. Okay, the moon cold and the sun thing, that's very easy to actually debunk. You can simply get an infrared, thermometer, and then, of course, account for the surface temperatures, infrared emissivity. You have to count for thermal conductivity and all that stuff. It's not that easy, but it can be done. You can see how much energy is being radiated, how much is being absorbed, or you can simply just get like a diode or something that's photosensitive and just measure the energy in the moon's light. It's not significant, but there is energy. That means there's kinetic force behind it, essentially, and therefore it heats up molecules. It makes molecules move faster, even if it's very minuscule. Oh yeah, another point you made was if the Earth is slowing or speeding up, you should be able to feel it. That is correct if it is significant enough for you to feel it. By that, I mean if you were to, shift by, let's say, like 15 degrees an hour, you might not realize it, because it's just essentially impossible for the human being to recognize that. It's actually, but you could measure it with a tool known as a gyroscope. Gyroscopes have this very cool property of kind of like, once you start spinning them, they kind of like fixed in space. It's really cool. And then if you rotate it, it spins 90 degrees.
1 minute,
so with a gyroscope, you can actually, because it kind of locks in the space, you can observe a 15-degree shift per hour. There's also something known as a Foucault pendulum. That's pretty cool too. And that works really good if you're on the North Pole. Actually, that is the best. But of course, I'll just yield the time.
All right. So this is your final round, Chris. 3, 2, 1.
All right, so I'm going to use this round to basically finish off the main reasons why I believe in this code. I'm not going to really refute his points, but I'm going to go into the last few parts. So another thing with the sun, if you guys look in the special events, the sun actually, when it moves away, it actually gets smaller due to your perspective. If the sun was millions of miles away, 93 million miles away, a slight turn should not change the size of the sun. If you take a look right here. One sec. I believe it's because the sun is smaller and closer to us, and when it moves away, it's actually because it is moving away and it's getting smaller. Another thing with the flat Earth model, with the globe model, is magnetic fields. They're saying that the core of the Earth is causing the magnetic field of the Earth, but molten iron loses its magnetism when it's heated. So that doesn't really make sense to me. Another thing is the flight patterns, right? So I noticed that the Mercator projection of the round Earth model, it actually does not account for circumnavigation of the globe, which doesn't make sense to me. That's why I know the flight paths are straight. Another thing is sun and moon anemonas, okay, and seasons on the globe. They're saying that in order for seasons to work on the globe, they actually think the tilt of the Earth is causing the seasons on the globe. But the thing is, just like I said earlier, the Earth is moving around the sun on an elliptical orbit. That means when the whole Earth is getting closer to the sun during the winter solstice. Okay, more sun rays is hitting the Earth. That's actually 3 million miles closer to the sun during the winter solstice. They're saying a tilt is causing winter in the north and summer in the south, when the whole Earth should be getting heated up because it's getting closer to the sun. Next point I have is the lack of curvature, right? So the curvature is 8 inches per mile squared. That means within 10 miles, this is within your own field of view. 10 miles is imagine a 10-mile drive. If you use 8 inches per mile squared, 10 miles is equivalent to about 66 feet worth of curvature. Think about a 6-story building within your own drive. You should be able to see that, and the higher up you go, you should be able to see curvature. If you strap a GoPro to a balloon, there should be a significant amount of curvature. And also, zooming out on lighthouses that are 30 miles away, you should see significant curvature, but yet water doesn't curve. It's not observable. Another thing is eclipses. During a lunar eclipse on the globe model, the lunar eclipse is glowing red, but the problem is if the sun rays are hitting the Earth at a parallel angle and the shadows are a lack of light, what's causing a lunar eclipse to glow red? When it's being obstructed by the Earth, because the Earth is bigger than the moon. And they're saying that the sun rays are bending around the sun rays are bending around the Earth. Which they also claim that gravity bends light, but I don't believe that in my model. I don't believe in the theory of relativity. What else? Also, stars. You're able to zoom in on the stars with a $700 camera when these things are a million miles away and they fully zoom into the field of view. That should be also impossible. Selene on eclipses. Let me think. I think that's it. I think that I'm going to yield the rest of my time.
Okay, Mechano, this is your final round, man. 3, 2, 1, go.
So I'm actually gonna, since this is my final round, I'm gonna have to cover a lot of shit real quick. I'll do that near the end. But I'm gonna first of all explain the red light. So there's something known as Rayleigh scattering, and you can actually observe this, and this is actually what causes the sky to appear blue. So by lower I mean smaller wavelengths scatter faster in the atmosphere. Therefore, the blue light starts scattering first and hits your eyes and everything else. And the more it goes through it, essentially the more high energy wavelengths are being absorbed and spread. That's why when it's the sun is at the horizon, it looks very orange and reddish, because that's essentially the only light that's hitting you. Everything else has been absorbed. That's what's also happening for a lunar eclipse. Is actually a sunset kind of on the moon, which is really beautiful if you think about it. It's fascinating. But yeah, that being said, the molten metal thing, that's true. Iron does actually lose its magnetism when it's molten, but you also have to consider the immense pressure that it is in the core, and we don't really understand the core very well, but it is solid. It's not liquid. It's solid. So we don't know if there is a lattice structure that's stable, that's magnetic. Who knows? Because it is solid, it is very possible that it is retaining its magnetism. So there's that. Now I'm gonna actually go over a bunch of experiments that we can do to prove how the Earth is round. Now, the Cavendish experiment with the weights, of course, I told you to add matter and just do rough calculation. You'll get a rough estimate of how massive the Earth has to be to have 9.8 meters per second. You just plug in the formula and you'll get it. There is, of course, the pendulum. There's, of course, barometers where you can, measure delta atmosphere, pressure. You can also do another cool experiment, which is, and again, you already believe in gravity, essentially, so I don't really need to say this, but for those that, think that there's Earth is accelerating up in 9.8 meters per second, if that was the case, there would be no delta gravity at all. It will be constant everywhere. So to disprove that, you just get a really, really powerful, very sensitive microgram scale, put it on a balloon, set it up, measure, and see if you notice any differences. And there's also this thing you said about vacuum somehow, affecting the Cavendish experiment. There is literally no effect on the Cavendish experiment, whether or not it's in a vacuum. I was just what we call it, humoring the idea that yes, we can do it in a vacuum, just for science reasons, why not? But the effect is negligible. And we can also measure that because, again, this isn't something off in space or something crazy. This is something in front of us where we can touch and manipulate in a lab. There's, of course, radar and satellites. We've been using this the whole time. Of course, there's problems with line of sight because the Earth is a sphere. And one ways of actually sending waves around the Earth is by bouncing it off of the ionosphere. Low wavelength. You can mute yourself, by the way. But yeah, low wavelength electromagnetic waves bounce off the ionosphere, while higher wavelength is actually absorbed. Then there's, of course, eclipses. That's thank you for mentioning that. The flat Earth model cannot explain eclipse, nor can it explain how half the Earth can be daytime and half the other half is like nighttime, and there's a perfect straight line in the middle. That's not how light expands. I'm sorry, it's circular. It will not create a straight line. There's no way in any light simulation, and I have software that can do that. There's no way you can create that line that exists. There's, of course, different star patterns on the southern and northern hemisphere. Cannot explain that. There is, of course, we can, of course, observe other heavenly bodies and notice that, wow, they're all spherical. Why are we different? And then, of course, there's the fact that the model that we're using today, the scientific community is using today, is one that fits all observations, but more importantly, can predict outcomes with striking precision. We have footage of boosters. We have footage of the moon before there was. I have seen that footage, by the way, is the camera thing. And that's actually a very fucking stupid illusion created by focus, out of focus, and turbulence. And you can actually do that with a light source and a freaking lighter. And I'll send you a video if I can of that. I remember Grizzly used to always bring that up. What else? Ships disappearing from the horizon. We see that all the time, but you can say this refraction. So I didn't even mention that. All right, I'm done.
So I believe that concludes the debate rounds, Molly.
That is all, my friend.
Hold on, guys. Hold on.
No, you hold on. Brand, shut the fuck up, and I'll tell you when you can speak. So that being said, thank you very much to our debaters. We just concluded 5 rounds each on the subject of flat Earth, with Machina arguing against flat Earth and Chris arguing in favor of flat Earth. So if one of our mods or anybody could set up a straw poll in the special events channel, that would be great, and then everybody will be able to vote. The choices should simply be Machina on the one choice and Chris on the other, and you just vote for who you think made a more persuasive case. Try not to let your prejudices or beliefs about the whether the Earth is flat or not determine your vote, but vote on who did a better job on the debate. Always up bigger if you could just close your mic for a second. Yeah, and then once that's set up, we're now going to open it up for free discussion. But I just wanted to thank Paulie. Great job moderating. Machina and Chris, thanks so much for doing the debate. You guys both have the master debater role now. Anybody who does a debate on the server gets the master debater prestige role. And that being said, everyone can now unmute yourself. If you want to talk about flat Earth, ask questions, make comments about the debate, go ahead and keep an eye on the special events channel and vote on who you thought did better. And thanks very much. And remember, every day at 8 p.m. Central, we're having special recorded events on the server.
One quick question before we move on. We're going to continue recording, and when should we stop recording? I would like if the question and answers are somewhat recorded, because I was nowhere near done, to be honest.
The debate format is only the beginning of the event. It's all recorded. Now we're in the open discussion part. So thank you for doing the debate. Now it's open discussion, but yeah, keep recording until the end of the event, which will be whenever we're bored, basically, or you have to go.
Hey guys, I'm sorry. I'm sorry I came in late because I have a lot to talk about with flat Earth and stuff. And personally, I do believe that there's one of two ways that we live on this Earth, and one is it's flat. The other is way bigger than what we hold.
I just heard there's two ways to live on this Earth. One of them is silence. The other one is way bigger.
Yep.
That's what I heard.
No, what I mean is,
I'm
sorry. Shogun, do you want me to explain that better to you? I can explain that better to you.
I thought the microphone dropped out and you just didn't finish your sentence.
No.
Wagwan, take a deep breath, Wagwan.
Chill. I think they need more than 5 rounds.
May I discuss my model?
Can Branch
no, Branch. We're yielding your mic time to Mr. In the Dryer. Branch,
man, trust me, man. I know
you came in too hot, Branch. You came in too hot, bro. All right, you got my.
All right. So I have this idea of a Dyson sphere Earth, where essentially that it combines into Matrix Earth, the idea, where it's sort of the Earth is inside out. So you point toward the ground and you say, look up. And through centripetal force, you could be adhering to the ground. And the sort of matrix idea, I'm trying to piece my thoughts together. The matrix idea, the world around us is highly computable. There's a mathematical constructs around us.
Can we go back into the questions?
Yeah. Okay. Chris and Deuce Mechana, do you guys have some questions do you guys want to get across to each other?
Well, I mean, the debate part is over, right? So anybody can talk. It is open. You can talk to each other. You can continue about flat Earth. Totally up to you.
I have questions, but I think, am I coming in clear or really bad right now?
I can hear you good.
You're coming in quite fine.
Good, brother.
Oh, well, I did want to ask the flat earther, is there a way that you can explain why, objects disappear in the distance? Because, I know that, a lot of people will just say that that's because of, the thickness of space or something about orgone energy or something. But, what's the flat earth perspective on that?
Everything obeys the law of perspective. Everything gets smaller and harder to see when it moves away. And yes, there is water in the atmosphere. Water does distort light. It depends on the atmospheric conditions. If it's hot, it can create mirage effects. But yes, the atmosphere can function like a lens.
The weird thing in my experience is
things get foggy when they move away.
Pardon. Man, I've encountered both experiences of flat Earth type phenomenon along with globe Earth type phenomenon, like the moon showing up in weird angles and looking like a holographic projection, while at other times things seem to be operating on a globe model just fine. And that's what's pointing me towards more of a matrix model.
I have a question that I wanted to ask. I couldn't, and I forgot because there was so many stuff. If that's cool, I'm gonna jump in and I'm gonna just mute myself. If there's a dome, then the thickness of the atmosphere has to be maximum at the center, or the North Pole, and it should be next to nothing at the edges. If that is true, we should be able to test it very easily, considering how thin the atmosphere really is.
Wait, why?
It's a dome, right?
Our mathematical models,
Okay.
there's no such thing as a true vacuum. It's just a continuous. The air gets less and less and less dense.
Hold on, let me answer this question.
Just where you draw the line in your model.
All right, so basically,
why did you do that? No, Flat Earth.
Because I'm trying to answer your question.
Yeah, but still, let him fucking finish, dude. Jesus, you just
I know,
muted him like why?
So you have various models. So you have to draw the line somewhere, and that's where you get to the whole expanding and contracting or potentially contracting universe. Because where do you draw the line to do the calculus? Create the model. Calculus is based on the continuous nature of reality, which ties into gravity. While we know with particles and atoms and whatnot that there's a discrete nature to reality as well. So we exist within some sort of paradox between the discrete and the continuous. We're both discrete and continuous at the same time. It's strange, but somehow it works, and it only seems contradictory in our minds sometimes.
I see. Well, thanks. Anyways, yeah. Sorry, Chris. You answer the question.
All right. So basically, you're saying that the pressure would be different on the sides, like near the south area, right?
No,
which is the perimeter of the flat Earth?
Not at all. What I'm saying is, if there's a dome, I'm just gonna, for this sake of simplicity, assume it's a glass dome or something like a glass dome. All right. So if you're at the edge, you're gonna be able to touch it essentially.
Yes.
Okay. Exactly. And the more you go towards the center, the further away the glass is from you vertically upwards. And if you're at the center, at the North Pole, according to your model, the height from the ground to the tip of the dome should be maximum, right?
Yeah.
Okay, good. So this is something that we can easily demonstrate that it's false. But, just is an interesting experiment that we can do. And if anybody, is, again, somewhat believes in the flat Earth and believes the entire world is in this giant conspiracy and almost everybody is lying and all the scientists are cuckoos, they're in this cult of science, as a lot of people like to say. If that is the case, then this is something that's worth pursuing, to disprove, right? Because again, very easy. Move towards the edge as much as you can. Shoot actually, this is what you should do. You should get this is to get the maximum range. You get an amateur rocket, not that expensive. You can make it, or you can get someone to make it for you. Then you have a helium balloon to launch. So it will take it up as high as possible. You don't even need the rocket, actually, because helium balloons can go really fucking high, especially if they're well made. So you know what? Screw the rocket design. Let's make it cheaper. So let's see what the maximum height is going to be for both of those. And we will be able to see that they're essentially identical and that there's going to be no difference whatsoever. And that's going to be very interesting.
Okay, so you're saying we should be able to go south and launch a rocket and hit the dome, right?
No, not even a rocket. Actually, no need for a rocket. A balloon should do just fine. Actually, a balloon should touch the dome from anywhere, actually, if it is,
literally ground level, right?
That's how they embed satellites on the dome.
Yeah. It's just, I'm down to discuss every little thing about it. Oh yeah, there's also the seismic patterns. That's a very important thing.
Yeah, the seismic patterns. Yeah, that is a point, man.
They prove.
The way they echo indicates
That would be
layered
interesting, y'all,
core.
if you did a balloon and saw how high it went, like with the helium, and have something to measure it, you know?
You can use a barometer, right?
Yeah, not just that. You can use an accelerometer, and a gyroscope. But accelerometer alone is enough. Really, it's all you need. A sensitive enough accelerometer, just like your phone. It has an accelerometer on it. You know, if it's accelerating from static to up. So let's say it was an inertial frame of reference, and it was
How do solid state accelerometers work?
It's really, really simple. You can even a scale can essentially work because acceleration can be detected very easily. Of course, there's also rotation and angular momentum, which can be easily detected with gyroscopes. And if you want to get very precise with it, you use optical gyroscopes. And I believe there was actually a bunch of people that wanted to disprove. Yeah, exactly. A bunch of people wanted to disprove it. You know what I mean? Disprove that the Earth is round. And they had this apparently optical gyroscope, and it actually turned out to prove that there was, in fact, a 15-degree shift.
Absolutely, there've been many fucking things that prove that type of shit, right? But hey, do you mind if I just like give one aspect of flat Earth that, which is essentially it's actually been my entire thing about flat Earth, right? And the way I see it is this: look, people that believe in flat Earth, right? The reason they believe in flat Earth is not because of the shape of the Earth, right? It's not got anything to do with anything with that whatsoever. The reason they do it is because, look, they feel themselves as people, they need a group to belong in. And when they find a group such as Flat Earth, if they find a home, they find an emotional home.
Don't overtalk.
Okay, I won't overtalk. Go ahead. I'm just saying.
Guys, hold on. I gotta go get an emotional home real quick.
Actually, hold on 1 second. Actually, Branch, you were not the one over talking. It was, I think, Holy Sepulchre that started over talking. So now just go ahead, Branch.
So I'm just saying, these people, right? What they do is, okay, I hate to say these people because it makes me like it sounds like I'm talking negative towards them. But look, essentially, look, society today has got these people in a point where they're basically looking for, if you want, kilometry, or they're basically looking for a home within a social status. And if the home they find is flat Earth, right, then regardless of what we tell them about why the Earth is not flat, it's not going to help.
Branch, are you living on this?
That's just saying. False emotional claim.
I'm just saying.
It's a very emotional claim.
Branch, are you living on this real quick?
Am I living on what? Am I living on what?
I put it in special events.
Am I living on what? I'm sorry.
Branch, are you living on that, Branch?
Do you believe you're living on this currently?
Living on what do you mean? But am I living on it? I don't get what you're trying to ask.
The Earth with Photoshop clouds.
Oh, am I living on the Earth? Yeah, I think it's
that right there. That picture.
My perspective of life. No.
What
I'm saying is this: Flat Earth is simply a way of people that have a like-minded way to congregate together and have fun, right? And
that's an oversimplification.
It is.
That's an oversimplification.
Most flat Earth
oversimplification.
Most flat Earth is
something that's a. I mean, they're doing a lot of testing themselves.
They do a lot of testing,
and they're learning. They're learning a lot about.
But listen, man, what
I
I'm
shouldn't
trying to
say they are, because I don't even know the geometry of the
This
Earth.
is more of a societal thing, bro.
I don't even know what we don't know.
Oh, trust me, man. I've actually looked into flat Earth for many years, and trust me, but this is my conclusion. Is that look,
I have a
flat
question
Earthers
for the
are
flat
there
earther.
because they want to be part of a society.
Yeah, what's your question?
My question
Talking louder doesn't make your argument stronger.
It doesn't.
Well,
I'm drunk,
Hayes asking a question.
and I wish I was sober right now because I probably could do better.
Yeah, we
Excuse
all wish
me.
you were sober, Branch. We always all wish you were sober. Okay, it's Hayes' turn.
Yeah, Chris. Is Earth in your view a plane or a flat Earth?
It's like a snow globe.
Okay, but Tesla, for example, he says that the Earth and most planets are planes. Do you subscribe to that, or is that the opposite of what you think?
No, he said the Earth was like a realm. I can show you the quote.
Right,
realm.
right.
Realm. I like that idea,
Chris,
man.
the better question is this, Chris.
You're saying it's
what was
totally
it?
different from what
No.
you're referring to.
Can you not interrupt him?
Branch,
Branch,
you're
shush,
starting to
shush.
interrupt people.
Sorry.
What'd you say, Hi?
You're saying it's totally different to the flat Earth model, then?
Well, no, actually, Tesla supported the flat Earth model. I don't know why. He says it was wrong. He didn't say that there were any other planets either. Like,
I like Tesla's quote of, if you want to understand the mysteries of the universe, you got to look into energy, frequency, and vibration.
Guys,
That's not true.
Okay, now I'm no longer interrupting anyone. So, Chris, let me ask you a question, bro. What made you get into flat Earth? What made you get into flat Earth,
Branch, you're
Chris?
trying to dominate the conversation.
Branch, you don't need to be an interviewer right now, okay, buddy? How about you just kind of, listen once in a while? You can say something, but like, try not to fucking rampage around through the conversation like a Branch.
Wait, can I ask a question?
Basically, I'm trying to get in. I'm trying to get into the concept of de Broglie waves. So each atom is both a particle and a wave at the same time, and so I think that hints at Tesla having an idea that energy, frequency, and vibration being quite fundamental to the cosmic makeup of this strange realm we live in.
Yeah. All right. So
Dude,
I'm gonna actually
quantum
ask
mechanics is insane.
a question to anyone that's actually interested in flat Earth and they truly, genuinely believe it. If you have any other serious questions that you have, by all means, feel free to shoot it by me.
Okay. Can I ask you a question? Why
Sure.
is the hurricanes and tornadoes rotate the opposite way, and then when you flush the toilet on one side of the Earth, it rotates one way, and the other toilet flushes the other way?
because Australia's toilets are different.
Yo, wait, can I ask you a question?
I was asked that question, so I'm going to answer that, and then by all means, you can feel free to go on afterwards.
effect.
So, yeah, it is the Coriolis effect, exactly. And yeah, you can actually go look it up yourself, but as I actually mentioned previously, it is really simple. You're the equator, the velocity, the angular momentum is faster, higher at that point, and at the North Pole, it's not. So if you were to move, let's just say from the North Pole to the equator, or vice versa, you would see that the ground essentially underneath would be kind of like shifting. Actually, that is a real thing, Coriolis effect. Bullets, you can do that very easy. There's also a room, a centrifuge room. That's pretty cool. You can visualize this and feel it. There's a video of it on YouTube and how it looks like. It's very nice. It's very cool. The Coriolis effect is simple like understanding of vectors and how it works. As you see it, it's very visual, very clear. And if you look at the animation and don't understand it, tell me which part confuses you and I'll explain.
So Coriolis effects works with toilets, but it doesn't work with hot air balloons, helicopters, planes. Yeah, I don't know. I don't think that was a good explanation.
Are you actually on a phone booth right now?
Hello?
Essentially, with the Coriolis effect, you
posted
have
a
a
video
certain
special
speed at
events
the equator, so you're moving 700 miles per hour or something.
Yeah, but you can't feel the spin when you're going higher up.
You're moving as you move along. You're changing your angle, and you're moving. You're spinning less, so it curves around. So as you move up, because you're moving at that speed at the angle, you keep on moving with that speed, right, as you change your position.
Yeah, but that don't make
If you had
sense
a
because why the hell it rotates the opposite way? Something's making it do it.
Yes, it is exactly. It's so simple.
It
The
makes perfect
hemispheres.
sense
That's the
because
geometry
you're
of the hemispheres. That is what's doing it. It is the geometry and the direction and where it lies on the hemisphere and the rotation of the Earth. These are all the things you need to understand it. Take a look. Seriously, I'm not going to explain it again. Just look at one simple animation on YouTube. Please do that. And if you really don't understand it after that, I will promise I'll do my best to explain it to you. We can go in a private call if you want.
Could the flat earther elaborate on the ice wall and like maybe why it may exist?
It's the perimeter of the flat Earth.
Can I
That's its only purpose.
elaborate
is
on the
to keep water in?
Coriolis effect?
Yeah.
The whole idea of Australia being upside down, et cetera. Well, that would, in essence, is sort of upside down if you want to use fixed directionality, and that's why it spins the other direction in the southern hemisphere.
I have actually a good question now that we were talking about the Coriolis effect. It is got to do with this rotation. Is the flat Earth rotating? Is it rotating? It's very important. It's not. There's no rotation. It's just a flat disk with zero rotation.
Yes.
What causes tides then?
Okay. Yeah, that's a very good question. Thank you.
Well, first things first. Let's address tides on your model. You believe the moon is causing the tides on the Earth, right?
Yeah.
Oh, okay.
Well,
but the moon rotates around the moon rotates around the Earth probably once every day, right?
No.
No.
Not at all. That's
Really?
Why, yeah. Once a month. You know, the month is a very big indicator.
So how often does the moon rotate around the Earth?
Once a month.
12 times a year, I think.
So
I mean, I don't know.
So once a month. Okay. So you're saying that tides are caused by this once a month movement, right?
No, it's caused by the Earth spinning around. Think about a month.
So why isn't there a huge?
Something moves a little bit in a month.
Why isn't there like a huge tidal wave every time the moon passes?
By the way,
don't interrupt them. Jesus Christ.
Something moves a little bit in a month, so it moves maybe like 2 or 3 degrees, and the Earth is spinning, and it spins once every 24 hours. And so you have the moon on one side, and it pulls it, and so that's why you have the 12-hour tides and the 20, and the geometry of the seafloors also affects the tides. So
I'm sorry.
So it's the Earth's spin itself that is related to the tides. That's why.
Materialist
that's why tides aren't exactly 24 hours, because the moon is moving relative to the Earth, and so the tides keep on shifting.
Materialist scientists do not agree that the moon causes the tides anymore. They think it has more to do with the sun. I'm pretty sure by now. You have to look into that more before. I think.
Hold on.
It seems doubtful.
Okay, in Canada we have the Bay of Fundy, and the Bay of Fundy. All right, and that is the largest tide in the whole entire world. Like, some of the levels come up 15, 20 feet. I think 30 feet in some spots.
Yep. Yeah, is that a 12-hour? It's a 12-hour tide. Or?
I think it's a 12-hour tide.
Yep.
And on the west coast of Canada, I think it's like every 8 hours.
And
what?
That's
is that really the case?
I think it is. I'm going to look it up right now. It's been a while.
That would start leaning towards matrix theory then.
Well, I know about the metrics. I figured out a metric mile is one. It takes the speed of light to go to the moon. Okay. What was it? Forgot. 1.3
It's
seconds.
It's 2 seconds. It's 2 seconds roughly.
Okay. No, it's
1
1.3.
second.
And then
1.3. Yeah.
Mars, it takes 3.3 seconds. Okay.
No, it's about three. It's about a. It's a couple hours. It's a couple hours to get to Mars.
No, minutes, I believe.
It's 3 minutes point 3. Okay, I'm telling you, I've researched this.
No, Mars is hours away, from what I understand.
Mars is 3 metric miles. That's what I'm calculating. I figured a new way.
Not metric miles, man. It's light. Sorry, but dude,
What is a metric mile?
Light seconds.
I've never heard of the idea of a metric mile before.
This is really kind of triggering me here. Real quick, hold on. This is light second. You're talking about light seconds. Light second is a unit of minutes. Don't say metric mile because that shit will fucking trigger the shit out of me. I'm sorry.
60. So
that is crazy.
Mackinac, I was only 35 metric miles from work to home today.
What the heck?
Well, speaking of light, I have a question.
A metric mile. That's an absurd idea.
I don't know what the hell it means, but it triggers Mackinac. So I'm going to be talking about metric miles. How many metric miles away from me are you right now, Technochamp?
I'd say I'm about 42 metric miles away.
It's not even a mile. It's only 1.3. That's 1/60 second.
42. You know the meaning of the universe, etc. Yeah. Kind of get it.
Because everything's close. I could aim at a star and I could pull a spirit out of the star system and throw them down to the ground in about 1 second.
Actually, about that, did you guys hear that the place of creation got destroyed? Are those photos of the crazy dust nebula stellar nurseries? They're like these finger type shaped things.
Did they really destroy them?
Supposedly they were actually destroyed. Supposedly there was like a supernova that destroyed the pillars of creation.
That's the horse.
Supernova is what created the pillars of creation. The cosmic dust. We wouldn't have the elements in our bodies today if it weren't for the stars dying for us.
I would also like to mention that we do have a mirror on the moon that you can bounce a laser off of, which is pretty cool. Again, for anyone that has any doubt that the Earth is round, any doubt whatsoever, just feel free to look at it from any angle whatsoever. I mean, just feel free. I want to kill this flat Earth bullshit. I'm sorry.
And the carbon in your left hand probably came from a different star than the carbon in your right hand. That is poetic.
If you drill to the center of the Earth, you could tell how thick it is, right? If you take a spaceship or a drilling machine and start here, wherever you at, and drive a hole straight to the Earth.
Your mic is very very muffled, holy sepulchral. Yeah, it's very muffled and.
Open Eye Project, whatever. But,
yeah, can you make your mic louder, man? Or
can you please? Closer? Yes, please. But if not, please keep going.
But I'm doing the Open Eye Project. Me and Shogun, we're supposed to do some the Open Eye Project, and he's gonna ask me question like a radio show does, right? And I don't know when we're gonna. But he's gonna decide. It's gonna be.
Well, we can do that tonight if you want, or we can do it tomorrow. But we should do it soon because it'll be a really interesting one.
It would be better if you had a better mic, though. Unfortunately.
Oh well, I'm on my Bluetooth. Let me turn my Bluetooth off and see what it sounds like. Okay?
I can hear him all right. Like he's not too bad.
It's just really quiet.
Okay, I could turn my mic up. Okay, my mic wasn't up.
You're not that quiet for me.
Yeah, it's coming through pretty well all right now.
Yeah,
I want to do this event, so yeah, if you're down, I might even do it. We could even do it tonight if you want, Septiker. Are we still recording? Yeah, we're still recording the flat Earth thing. We should probably end that now. So why don't we end the flat Earth thing now? Because that was good.
I was gonna ask.
Yeah, really good.
Before you
and
end
so
it.
just jump to the roundtable general chat for free discussion. Thank you, Machina, for debating on behalf of Spherical Earth. And Chris has left the room, but thank you, Chris, for debating on behalf of Flat Earth. Thank you, everybody, for coming out. And please do join us on the Roundtable Discord server. Find us through Disboard, Disboard, and go to Conspiracy or Politics, and you'll find Roundtable at the top. Or just Google Roundtable Discord, or find us on social media, YouTube, Facebook, Google, Tumblr, Twitch, Reddit, Periscope, GoFundMe, whatever, Instagram, all that. That being said, thank you very much, everybody. Good job. What shape is the Earth? You decide, America and planet.
Russian users.